I sure hope you had a lovely break. Busy, but still nice.
We've actually only got to be there for half a day. Ended up being there for all 3 days.
Oof. Is that good?
It was for a little while.
I was gonna say you're on recording. Careful how you answer that. So.
Don't worry, she doesn't know it easy.
Okay.
Yeah, that was funny. That one, yeah, he got. Okay, you said a very. You need to calm down.
So before break, we did absolute value equations. I thought it was pretty easy, right? You get the absolute value by itself, split it into the two equations, solve them both. Straightforward. This is a more complex sort of lesson. I'm going to knock this out in a couple different parts. So we're going to stay away today from the ones that are the weird ones, the ones that have no solution or infinite solutions. So today you won't see any of that. If it happens to come up in the notes, it was an accident and I'll fix it. So today's are all just going to be, let's learn the procedure, the mechanics of how to solve these bad boys. That's the goal for today. And then we'll practice, okay? This has been, and now you guys have proven to me, we're almost done with a semester. We're 4 weeks from semester. And you've proven all throughout the year that things that I've always thought cause people trouble have generally not caused you much trouble. So we seem to be having a pretty kick booty year. But I would just tell you from where I sit that this has been a trouble spot. Right? What happens with this lesson is everyone thinks, oh yeah, it's easy. I got this. And then when it comes down to it, it doesn't generally go that way. But again, you've been proving me wrong all year. So hopefully that trend continues and you just go, yeah, this is easy. So we're going to start with just sort of a couple of conceptual sort of problems and make sure you understand why we're doing what we're doing. If these first couple don't make sense, it's imperative that you stop me and say, you need to try that again. Say that again. That doesn't make sense. So rather than saying that the absolute value of something equals something else, we're going to start by saying that the absolute value of something is less than 4. So at this point, I can't say that there is a number that makes this true. Remember, when it was equations, I could say, oh, x could equal 4 or x could equal -4, right? I was looking for those specific targeted numbers that made an equation true. Today and tomorrow and probably the next day, we're not searching for a number that makes something true. We're searching for an infinitely large package or set of numbers that make something true. So if you think about this, what I'm asking you in this equation or in this inequality, excuse me, is to find me a description of every single number in the universe that is closer to 0 than 4 steps. And right away, your brain should be trying to understand, okay, what does that mean? That means that I can be, if this is 0 here, I can be anywhere closer to 0 than -4, and I can be anywhere closer to 0 than +4. And what you realize now is, again, there's not a number or two numbers that make this work. There's an entire long package of numbers that makes this work. So if I were to make a physical description of what this looks like, and put it on a number line, I would always put 0 in the center. I won't always do this. Just for this example and the next one, I am going to put 0 in the center because 0 serves as like the magnet, the tractor beam from Star Wars, the thing that like just sucks things inwards. And so if 0 is in the center, I can stick -4 over here, and I can stick +4 over here. If I think about the description, the problem, the inequality that says x can be anything whose absolute value is less than 4, I can start peppering my number line with dots and just ask you, like, Does that work? Does that work? Does that work? Does that work? That one? That one. And what starts to happen, what starts to materialize right before your eyes is you realize, okay, this is a set of numbers. It is continuous, but not endless. It starts existing at -4, and then there's a bunch of numbers that work, and then it ceases existence at +4. If I were to stick a point like this green one out here, you'd say that one's not a solution, right? It literally breaks what the problem says. Its distance from 0 is not less than 4, right? So the red points are good. I probably should have picked green for good and red for bad, but the red points are all solutions to this problem. So the question becomes, how do I denote that? Like, how do I write that down using math language in a way that someone would understand? Let me ask you this question. Does that yellow point work? Not in this case, it doesn't, does it? Because the inequality sign right here is very specific, and it says you cannot be 4 steps away from 0. You have to be closer than 4 steps from 0. So the yellow points in this diagram up here do not work. And in mathematics, we have a way to show that, right? We use just regular less thans or regular greater thans, not the or equal to variety. So let me first show you what an official graph of this would look like. I'm going to delete all my little points here, and I'm going to show you officially what this would start as, like this. I would put a circle at -4, and I would leave it open. And I would put a circle at +4, and I would leave it open. You'll remember these from Algebra 1 when we solved and graphed little linear inequalities, how on the number line we use either closed circles or open circles. The open circles denote I'm not in this. I'm a boundary. I'm where stuff starts to happen, but not right at me. I set a boundary. And then everything in between those two circles, you agree, would be shaded in. So that is not my final point. What I'm working towards here, these last few minutes of monologue, have been to get you to what I'm about to write. And I'm going to write it in red. And then I'm going to tell you what his name is. And there's a way very specifically that all math people want you to write this type of situation. And it goes like this. -4 is less than x is less than 4. I want you to study that, write it down, drink it in. Let's think about what it says. And as you ponder, just FYI, that's a very math nerdy way of saying the following sentence. X is between -4 and 4. If you think about it, there are two problems that are built into this, and I'm going to underline them using different colors for you. First off, the yellow one. If you were to read that to me, I'm not trying to insult you by asking you to read, but I want you to read it to me out loud, but I want you to read it from the direction of the X first. So read me the yellow one from the X. What would it say? Good perspective, you guys. X is greater than -4. So that's basically setting the boundary over here from -4 and saying, go that way. Now, if I do the purple one and read that to me from the X, what does it say? So that's setting the boundary from +4 and saying go this way. And as you can, of course, understand, if you set a wash from the left coming to the right and from the right coming to the left, those washes eventually collide into like a pool, right? And that pool exists only within those boundaries. If it were just one of them, then the line could go on forever. If it were just this one, the line could go on forever. But because they collide in the center, then both boundaries hold true and the wash happens in the middle, and that's where the solutions all lie. This, you'll be saying these words more than you can possibly imagine in the coming week or so. This usually takes a week. Again, you guys have proven to be pretty sharp, but this is what we fondly, and by we, I mean like just in my class, will come to know as a squisher. And I started calling them squishers so long ago, and it always made so much sense. And I think you'll find that it makes sense as well, because we're squishing the solutions inwards from the outside. We're like taking boundary, squishing inwards. So when you write an inequality like this one, where it's left boundary is less than x is less than right boundary, for our common day-to-day language, we're going to refer to that as a squisher. So far, so good. All right. Now we're going to change it up. And we're going to do what to you might appear to be the same-ish problem. We're going to say x is the absolute value of x, is greater than 4. So this time what I'm saying to you is the dead opposite of what I said to you last time. Last time I said x could be anything that was inside that walking distance, right? This time it's the exact opposite. This time all of the x's that are quote unquote solutions or that work, they're outside that distance. So if we were, again, and I will always do it, with a number line. If I teach this lesson 100 more times, I will never not teach it conceptually the first time without a number line. It just won't happen. So I want my 0 because 0 is the centering point. 0 is like where the ground zero of this problem is. And then I'm going to put in my -4 on the left, and I'm going to put in my +4 on the right. And if you start thinking this time about what numbers are good, and I guess I'll stay consistent and go back to red again, since I don't want to change it up on you. If someone was watching the video, I don't want them to get confused. Is that red dot a solution? It's not, is it? It's too close. It's breaking what the problem says. The problem says I have one requirement of you. If you're going to be a solution to me, you'd better be more than 4 steps away from 0. So the red is no go, right? But that's a solution. That's a solution. And look, so are those over there. We start to find now that the solutions are not being pulled into 0, but rather like a blast radius, they're being pressed away from 0 to the outside. So if I were to sketch a graph of it this time, I can't mash it. I can't squish it in towards the center. My graph this time goes out and requires arrowheads this time, because there's no limit as to how far out I can go. I can be anywhere to the right of 4, and I can be anywhere to the left of -4, and I am a solution. What kind of boundary circles will I put at my boundaries? Open again. So these are going to be hollow circles. You will not have to graph in today's assignment. But again, this all leads me to my point, and that is, how do I write that white absolute value inequality in a way that does not have an absolute value like I did last time? Pricey? It won't look like I did last time. It will look completely different. You cannot, I'm saying this, if you're still, I'm getting to my 10-minute mark where you might start dozing off. You cannot write this the way you did the last one. You're on to something, but pretty far off the mark, but definitely the right idea. First off, let me ask you this. Could you be in both of those red arrows at the same time? It's impossible. If I point to any point on this graph in the red, I can't say I can be over there and over there at the same time, can I? So this is not an and situation. If you use the word and with this, you're going to get busted 100% of the time, because Gabe can't pick a point, a number, and say, look, it's on the left arrow and it's on the right arrow. So we have to switch to the word or. And that is hugely important. Write it down. This particular type of inequality that we're writing right now requires the use of the word or. You can be in the left side or you can be in the right side. You cannot be both. So and is a big busta. Get you busted. So easier than you think. Could someone describe that left arrow to me? Just what does it say? What does X have to be? That's it. Can someone describe this arrow on the right to me? And that's it. This you will come to lovingly know. And again, you'll say this word hundreds of times in the next week. This is what I refer to as a splitter. As far as I'm concerned, when we're doing absolute value inequalities, we're going to convert them either into squishers or splitters, depending on the situation. No, no squatters, please. That sounds like someone taking a poop. So to this point, before we actually, because now we're going to do actual math problems, do you have any questions about conceptually why they get written the two different ways? Why one of them has to be a squisher and one of them has to be a splitter? Do we understand that? It's all based on, am I close to zero being pulled in, or am I being blasted away from zero by a greater than distance? So that's the awkward introduction. Let's get to it. So I'm going to give you an absolute value inequality, and your job is to write it as either a squisher or a splitter. And by the way, both squishers and splitters are called compound inequalities. I don't really care if you know that right now, but that's what we're trying to do, is convert absolute value problems into compound problems. That's the big goal here. So So one of the primary goals for this lesson is to get you to answer this question. And don't let 4 people say it while 13 or 14 of you sit anonymously and enjoy that they're speaking for you. Make sure you know this or speak up. By looking at it, can you tell me, is it a splitter or a squisher? It is a splitter. It's one of these, right? Like Seth said, it's one of these, because my distance from zero is being, someone's barking orders at me saying your distance from zero has to be more than a given distance, right? So that's when I know I'm pushing outwards, and that's going to split away from zero. So step 1 is to write it as a compound inequality. So one of them is going to say, okay, x minus 2, I need you to be to the left of -3. I just set a boundary and pushed all the values to the left. Because it's a splitter, I 100% have to write the word or. I've taken off lots and lots of hundreds of points over my career because kids think that the or is a cosmetic sort of detail. It's important. I'm stating I can be here or here, but not both at the same time. What will the other side of the problem say? Is greater than 3. And I can't, one of the things about teaching, one of the realities is you can't make a kid listen. You can't make a kid think. But of massive importance in this first 5-10 minutes of this is that you understand, just intrinsically understand, why those two symbols that I've just circled look the way they do. I can be to the left of the negative number, or I can be to the right of the positive number. So less than the negative or greater than the positive. Now, it's not the final answer, right? Because I don't have x by itself. So let's look at the left side and the right side. On the left side, how would I get x by itself over here? Add 2, right? That's light work. So x is less than, what's -3 plus 2? Good job. So that's 1/2 of my answer. I've now stated that to be in the solution club, you can be to the left of negative. On the other side, the algebra that I do is identical. I have to add 2 and I get what? X is. And if I were to put a box around this and say, this is my final answer, would I get full credit? No. What did I forget? Or. I forgot or. Again, that or is so massive. Tells the math gods, I understand I can't be in these two places at the same time. I can be in one or the other. Now, you won't have to do this in today's assignment, but I feel like this lesson would be incomplete if we didn't go through this. So just know that in your Delta math, you won't have to do what we're about to do, but normally when we do work on paper, you will. So what we're going to do is we're going to make a number line. And I no longer think I need to put 0. 0 doesn't serve the same important purpose that he once did. That was for the conceptual introduction to the lesson. So all I'm going to do here is I'm going to mark my boundaries. There's a boundary at -1, and there's a boundary at +5. That's all you need. What kind of circle boundaries am I going to put? Open. And how's my graph going to go? Going to split, right? So from -1, I'm going to head to the west, saying I can go anywhere less than -1, and I'm fine. And from +5, I'm going to split out to the east, saying I can be anyone bigger than 5. So if you're in either of those two sets of numbers, then you are a solution to the original problem. So far, so good. Okay. Next example. The absolute value of x plus 6 is less than or equal to 8. Squisher or splitter? This one's a squisher, and it's all in the little things. If it says less than, like in its final ready to go state, if it says less than, it's a squisher. So anyone want to take a shot at setting up this squisher for me? You said some really good things. However, a couple of issues. Number one, you said or. And with squishers, or is not actually in play because I can be, and I'm going to say what you said because your voice may not have gotten picked up by the recording, but what you said was really cool. You said that you can be less than +8 or greater than -8, right? But stop and think for a second. If -8's over here or +8's over here and -8's over here, if you come less than this way and greater than this way, you see that there is a set of numbers. There's that pool of numbers that work for both, right? Seth, you want to clean it up?
So -8 is less than x plus 6. And that is less than 8.
Good job. And you forgot the equals, but I'm not worried about that. I'm impressed with the structure. So this is how you write a squisher. Set left boundary, -8. Copy inequality sign, cream filling in the center, recopy inequality sign, set right boundary. Perfect squisher. And it's very similar to what Sutter said. What Sutter was saying was basically all of that. It's just we need to package it together in a certain way to express to the math gods that we understand that these two statements can and I mean they can be simultaneously true. I can be to the right of -8 while also being to the left of +8. And that's why we elect to write squishers like this and not separate it out. You don't have to use the word and when you're writing a squisher. It flows off the tongue like this. -8 is less than or equal to x plus 6 is less than or equal to 8. There's no pause. You just read it left to right, like that. That's where the primary questions are going to come. The bulk of the questions are going to be from the conversion stage, where we convert from an absolute value into a compound. The algebra now, I think, is pretty straightforward. How do we get x by himself? From all sides. And normally we say two sides, but this is like a three-headed monster, right? It's got three sides, a left, a center, and a right. And so when I subtract 6, I'm going to show my work just this one time. I'm actually subtracting it from all three sides. And that finishes the job. These 6's are going to cancel. And I'm going to be left with my final answer, which is what? Is Yep. And again, you don't even have to say which is. Not that I don't want to split hairs, but it just rolls off the tongue. Negative 14 is less than or equal to x is less than or equal to 2. You just never pause. You just keep reading it left to right. So again, not in today's assignment, but let's practice making graphs for when we get to our paper assignments. And so we sketch a number line, and you just have to set your boundaries. You don't need a bunch of little tick marks. You don't need a 0. You need to set a boundary at negative 14. You need to set a boundary at positive 2. What kind of boundary circles will I have? Filled in, solid this time, because the boundary points are included by the inequality sign with the or equal to. So we have a solid boundary on both sides like this. And where will my shadings go? Inside. No arrowheads this time. Remember, when two kind of arrows collide, they wash out, collide into a pool like this. So your shading should just go in the center this time. You feeling good so far? If you're good so far, then the rest is just icing on the cake. All I'm going to do now for the rest of this lesson is give you problems where there's a little bit of work on the front end to do, like this. I said like the battle cry. I said this last week. Might have been the week before. I don't know. Get the absolute value by itself. It's like if you're even right now thinking about is it a squisher or a splitter, that's premature. You don't want to make that decision until you've gotten the thing by itself. So what is step 1? Yeah, you just know. You got like your spidey sense, your algebra instincts that you've built up. Let's get rid of the 3. So we're left with 4 times the thing we're trying to get by itself is greater than or equal to 11 minus 3 is 8. Last step, divide by 4, right? So we're going to be left with thing we're trying to get by itself is greater than or equal to 8 divided by 4 is 2. It's at this point, like with equations, where now you can draw a line and say, this is go time. This is where I make my decision. And with equations, they're always splitters. Last week, they're all splitters. You split them, split them, split them. Not always true with these. Is this a splitter or a squisher? This one is a splitter. So this time, I cannot write it like I did the last problem. I can't set it as negative is less than x is less than positive. It will not. It doesn't make logical sense because you can't do 2 things at once. You can't be in 2 places at once. So let's talk about the left side of this first. What's the left inequality going to say? Absolute perfect left side. You set that boundary at negative 2 and say, I can be over there to the left on that small side. All right. What's next? You guys like that? You should be up in arms about the fact that we don't have or, but now we do. Good. So there's your splitter in all of its beauty, all of its glory. And now we just have to do a little rinky dink 6th, 7th grade math. Let's add 10. And I'm sorry if you struggle with adding 10, but that's a you problem, right? So if I add 10 to both sides of this first one, what do I get? X is less than or equal to 8. Or on the other side, if I add 10, what do I get? So this is what you would type in to Delta Math. If it were a paper assignment, you would go a step further. You'd make a number line. You would set your boundaries. You would set them at 8 and at 12. What kind of circles will we have here? Closed, right? Because if there's an or equals, then the boundaries are in play. So I set a boundary at 8 and I say, you're included. And I set my boundary at 12 and I say, you're also included. And where will my shading go? split out is a good way to say that. Out from the 8, out from the 12. I cannot be in both of these places at once. I cannot be less than 8 while also being greater than 12. Hence the graphs that look like this. Good. Sorry, did I scroll too fast? Let me go back up. I'm sorry about that. You're welcome. Next one. Can I scroll? Okay. You're welcome. Again, if you're already thinking about whether it's a splitter or a squisher, just don't go there. We're not at that crossroads yet where we draw that line and make a decision, make a call. So we've got some introductory prep work to do, some vegetables to prep, cut before we can cook the meal here, right? So what's step 1 going to be? Let's get rid of that 8, right? So we're left still with the opposite of the thing we're trying to get by itself is still less than or equal to. And again, you can't mess this up. You're in an 11th grade math class. What's negative 15 plus 8? It's negative 7. Always will be. We're still not ready to pass judgment. I'm still not ready to draw that purple line yet because I don't have the absolute value by itself. What do I have to do? Divide by the negative, right? And going all the way back to algebra 1, if you have a very good memory, you'll remember this. Anyone remember what happens when we divide an inequality by a negative? You do. It's just one little obscure rule, and it doesn't happen a lot, but when it does, you want to be prepared. When you multiply or divide with an equation, no one cares. But with an inequality, you have to take this Pac-Man and give it the 180. It's going to go whoop and mirror itself to the other side. So now I'm almost there. I'm almost ready to pass judgment. I can say, finally, thing I was trying to get by itself is greater than or equal to what? And it's at this point now that I draw my purple line and I can now pass judgment. Yes. No, when you divide, you are not penetrating any of this.
Okay.
Do you understand? Nothing inside of there gets tinkered with until we split or squish. Once we convert it, then it's open season and all that stuff. Good. So here we are. We've arrived at the crossroads. Is this a splitter or a squisher? It's a splitter. What's the left side of my splitter going to say? I think you went ahead of me there. So in its raw form from right here, we agree that this is a splitter. So what will the first splitter half say? Take this stuff. To say it, Bryce, go ahead. Yeah, but I like to be structured about this. So I'm going to do my uh, leftward one over here. And I'm sorry I don't mean to micromanage, but I think if we're consistent, this will help us. So 5 minus 2x is what? Less than or equal to negative 7. That's me setting that boundary on the left side and saying, go left. You can go anywhere over there. And then I put or. What's my other side of my splitter say? There they are. Again, it's not nuancy little stuff. It's not little details. This and this are the meat and potatoes of this entire lesson. I can be left of the negative or I can be right of the positive, but I cannot be both. Good so far? Let's solve. One on the left, what do we do? Basic algebra. What do we solve this? Subtract 5 from both sides. You get negative 2x is less than or equal to negative 12. Let's divide both sides by negative 2. What do we get? Top notch. I had to switch the sign, right? Because we divided by negative 2. Let's head over to the right side. The algebra doesn't change. The mechanics of the answers to the questions, what do we do? What do we do? Those are always the same. Now, what we get is not the same, but the algebra is still the same. You're still going to get rid of the 5. You're going to divide by the negative 2, right? So if I subtract 5 over here on this one, I get negative 2x is still greater than or equal to 7 minus 5 is 2. Divide both sides by negative 2. What do we get? Just the number part is of no interest to me. When you say negative 1, it means squat to me. The structure of the answer is the key. I need a complete sentence. Yes. I mean, I know you know 2 divided by negative 2. I am interested in the structure, that full sentence, the full verb, the full action. Did you notice how my splitter got crisscrossed? That's okay. That'll happen when there's negatives mooking around in the works. It's okay. So I'm not an idiot. So when I go to graph this, I'm going to show the world that I'm not an idiot. I'm still going to set my boundaries relatively where I know they should go, right? You can only imagine how much fun I'm going to have at your expense if you do this. You deserve every ounce of what you get if you do that, right? So just because the answers wound up looking like that doesn't mean that I'm going to forget what I know about the number line. I'm going to set my boundaries still correctly where they flip and belong. So negative 1 boundary is over here. 6 boundary is, of course, over here. What kind of circle boundaries will I have? Filled in on both ends. And where will I go? Out. This one literally says go to the left of negative 1. This one says go to the right of positive 6. And there's a completed splitter. Want to do one more example, and then it's going to be a little bit of work time today. A little today, a lot tomorrow. All right. Add 4, right? Divide by 6. We're not in the past judgment stage yet. We're not in the is it a splitter or a squisher. We're not there. So if I add 4 to both sides, I'm left with 6 times the thing that I'm trying to get by itself is still less than 2 plus 4, which is 6. Next step. Sí, tenemos que dividir los dos lados por 6, como esto. Right? Look at me showing my work like a champ. So now I'm at the point where I can say, thing I was trying to get by itself, you are now by yourself, and you are less than 1. This is where I, in my notes, physically draw a line. You don't have to, but it's a good habit. It reminds you when you draw that line that I'm at the crossroads now. One of 4 things is going to happen. It's either going to be no solution, all real numbers, splitter, or squisher. And again, we're only talking about splitters and squishers today. So I only have 2 choices. Which one is this? This is a squisher. And if you've made it this far into the lesson and haven't gotten this memo, let me summarize this for you, and you can write this down. If it's a greater than, or if it's a greater than or equal to, that's a splitter. And if it's a less than, or if it's a less than or equal to, I realize there have been instances in my career where I've taught this entire lesson and people have walked away from the whole lesson not understanding that yellow box. You got to make that call. Is it split or does it squish? So this one squishes. Here we go. What's it going to say? If the first thing out of your mouth is X, I'm going to cut you off right away, because with squishers, we do not start there. What's it going to say?
Negative.
That's how you write a squisher, like that. Your boundaries are established and you squish the cream filling in the middle, and both your Pac-Mans waka waka to the right. Now, the math, I think, is pretty simple. On this three-headed monster, how do we solve for X? We subtract 1. What do we get over here on the left? -2 is less than X is less than 0. Finished product. All right, let's make this official. Let's complete these notes. Let's make a number line. Remember, you don't need a whole bunch of stuff. You need to set boundaries. -2 and 0 are all I care about. What kind of boundary circles will I have? Open. Do not color them in. That's your way of telling people that -2 and 0 set the boundaries, but they don't work. They're right on the cusp, but they don't work. And where will the shading go? Inside. That is that. Your assignment is on the old Delta math. I expect you could knock out 4 or 5 problems here today. All right, I'll keep the recording going, but paused. If you have any questions, then I can do a problem on the board for you.